This is Dr. Sirisha, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to look at the basics, that is the course description of on outcome-based education with the course data structures. Let's start with course objectives. So what are the basic objectives of our course? That is data structures. So it is by the end of the day, the student will be able to understand, and during the course he'll try to learn the basic skills of data structures, what a data structure is, how data is arranged, what are the various forms in which we can arrange the data, and literally speaking, how they'll be stored in the memory locations will be taught in this course. So this course is a vital course in case of placements, and this is one of the core courses of computer science and engineering as well as information technology also. So all the competitive exams, say for your further studies, GATE and all, data structures plays a key role. So coming to, let's go in brief of what these course objectives are. So one of the important course objective is it provides students with the skills needed to understand and analyze performance and trade-offs of different algorithms. What it means is for any problem there will be n number of solutions, accumulative of all these solutions, and to evaluate, and or you can say to go for performance analysis of these algorithms using asymptotic, we call that as asymptotic analysis, and a mathematical tool for that is asymptotic notations. And the basic asymptotic notations which you're going to learn are theta notation, big O notation, and omega notation to evaluate or to estimate the performance of these algorithms, so that we can get an optimal solution for a given problem, right? So basically, we are going to first of all start with how to address the solution of a given problem in a form of an algorithm, that is step by step representation that you'll learn. Next, coming to the knowledge, the basic knowledge of that is basic abstract data types you are going to learn. What are the basic abstract data types which are associated to your data structures? So initial, the primitive data structures which are required, which you see in your programming, is integers, float, character, pointers, all these, whose definition is already defined. They're also known as built-in data types, whose definition has already been defined by the compiler. Coming to these abstract data types, these are the ones which will be defined by the user. We can even say that they are the derived ones. The examples say stacks, queues, lists, trees, graphs, so on and so forth, right? So stacks and queues are linear data structures you are going to learn, and the non-linear data structures are trees and graphs. We are going to learn how these stacks and queues will be implemented using arrays as well as linked lists. And you'll the on the core, when you go deep inside into this second objective, you'll be able to understand what an array is and what a linked list, and what is the basic difference between these two, how linked lists are better than arrays in certain situations, and how arrays are more flexible when compared to linked list. Okay, so and have to implement stacks and queues into a working model with the help of arrays and linked list, we are going to see. Okay, the same with the nonlinear data structures also, that is trees and queues. You'll be learning how to implement a tree or a graph with the basic data structures, right? And where they are applied. All the linear and non-linear data structures, you'll be looking at what are their pros and cons and the real-time applications of them. Okay, so using these data structures, you'll be learning how to search the data, how to sort the data, what is hashing, how we are going to resolve hash collisions, right? And what are the various types within stacks queues? In queues, you know that there are different types of queues are there, like circular queues, the double-ended queues, many more, right? Those things you are going to check it out. And coming to sorting techniques, various sorting techniques are there, like bubble, insertion, selection, quick, merge, and all. All these sorting techniques you'll be learning. Then the third objective is the fundamentals of how to store, retrieve, and process data efficiently. Right? Data will be in various forms, and the way we use it, it also depends upon the situation. Right? For example, let me take a simple scenario. Say, let me take the first example as a case where, mm, uh, yes, a buffer. Let me take the first example as buffer. So, what do you mean by buffer? Storing the data, right? Storing the data. Why would use a buffer? Temporarily, the data is stored and then it is retrieved for working on it, for operating on it, right? So, what kind of data structure is best useful to implement a buffer, which is nothing but a queue? Because it depends upon first in, first out. The element which first entered into it will go out first, right? So we will be when you get strong into the fundamentals of data structures, you will be able to decide in what application which type of data structure you are supposed to use. For example, file system, say take. Okay, which type of data structure is used? Obviously, it is a tree data structure, a non-linear data structure, which is a tree, will be used for file systems. Okay, then coming to one more application within our system, let me take an example of okay, one more application can be expression evaluation. How to evaluate an expression. Okay, for that, stacks are the best or the only suitable I can say. So last in first out, the element which was last inserted or accessed will be the one which is be popped out first. So which expression evaluations need, right? So for that stacks are best. For example, let me take one more and the last example. For example, maps, or you can send Google Maps, or you can in any social media you might have seen friend requests or mutual friends. Someone might be pinging you saying that I'm a mutual friend of your so and so friend. So all these friend mapping, right? This will be done with the help of graphs, which is again a nonlinear data structure. All the four scenarios which I have considered are real time applications. So it depends upon the scenario. So to implement a file system, you cannot expect a linear data structure like a stack or queue to be used, right? And for expression evaluation, you cannot expect a graph to perform that, right? So each and every data structure, whether it is a linear or non-linear, they are designed for a specific reason and they're used for the same, right? So you'll be able to understand the fundamentals of working with them. And coming to the fundamentals, what are those fundamental operations? So searching for a database or inserting a data, deleting a data, right? All if you want to do any manipulations, that is updations or deletions, everything comes under the fundamental operations of fundamental operations on these data structures. Next is to provide practice by specifying and implementing these data structures and algorithms in Python. So whatever the real-time applications we have discussed it just now can be implemented practically using Python. So when you learn data structures is a fundamental phenomenon which exists in our computers for proper working of a computer. See, for memory management, for resource allocations, queues are used, right? So all whatever the operations for memory management, queues are used. For functions, stacks are used, right? So for compilers use stack, for parenthesis balancing, right? So all these internally, all these data structures are most frequently used for the implementation or the smooth running of a computer, right? So analyzing them, understanding them is the one which we have to do. So being a student, you'll be taught the basics of it and the basic operations, and have to implement it with the help of Python. With the help of Python programming language, which is an open source and which is still being in an it is an evolving state. Still, in frequent few months, you will be getting new version of your Python. Right now 3.9.9 or somewhat is the latest version. We don't know, we never know. By this weekend, you'll get one more version of Python. It is the evolving one, and with the help of Python, you guys will be learning the basics of data structures and how operations will be performed on data structures, right? And this for future programming and to become a software engineer, this course is an essential one. As I said, even if you go for a placement or for further studies, this becomes one of the core subjects of computer science, right? So these are the objectives, and this is what you will try to learn. A student will try to learn during the course of data structures. So let's go to the outcomes. So once you learn all these things, what is the outcome? The first and foremost outcome is you'll be able to carry out the analysis of a range of algorithms. Look at CO1, guys. Okay, in terms of algorithm analysis and express algorithms complexities using big O notation. Okay, so for any problem, you'll be able to, any software problem. And please confine my discussion to computer science and engineering only. That is IT or whatever, engineering concepts only. Okay, then let me continue. So every problem can be represented with a solution in a stepwise form, and these steps can vary in n number of ways. So you will be able to judge which algorithm is most suitable for the given problem, right? So for every problem, we will be striking with an n number of solutions. But let me give a small scenario to you. For example, there is the first question. The question says that mm, evaluate the sum of digits of a given number. This is one problem. And the second one is evaluate the sum of a four-digit number. So when you look in a broader sense, these two questions are similar. What you are doing, you are reading a number and you are calculating the summation of the digits within the number. First question says that you have to add the digits of a given number, but second question precisely tells you that you have to add a given digits of four-digit number, right? So the hairline difference between these two questions is the first question there is a question mark on how many number of digits you will be using, right? Whereas in the second one, you know that you will be exactly using four-digit number. Four digits will be pakka, neither one less nor one more. But in the first question, you don't have clarity of that. For example, in the first test case, I'll be giving 12. In the second test case, I might be giving 123. In the third test case, I might be giving 1234. The number of digits may vary, right? So, what type of logic you have to use? So, obviously you have to repeatedly do the same operation. You have two options in your hands, either to use a for loop or a while loop. Am I right? So choose one. So for the first one, which is preferable? So you can use for and while for the first as well as the second problem. That is evident. No problem in that. But which one is best suitable? That is my point, right? So generally a cases where we know how many number of times we have to run the loop, we go for. And the case we do not know how many times we have to run the piece of code, we go for while. This will be wise decision, right? So for the first problem, solve it using while. For the second problem, solve it using for, right? So what I want to convey you guys with this example is CO1, that is your course outcome 1. You will be able to judge what type of logic you have to use, what type of algorithm you have to use. You'll be able to judge that with less complexity, which one will be used by the end of this course. That is your first and major outcome of this course. Second one, make use of recursive algorithm design in appropriate context. Very good. So, recursive algorithm, it has come from the most famous, you might have heard, recursive functions, right? What do you mean by recursive function? A function calling itself is nothing but a recursive function, right? So, you'll be able to judge whether you have to use a normal function or a recursive function, right? So, for example, let me take one more example for this one, calculating the factorial of a number. Okay, it's a very simple and a tiny task for you, right? So, factorial, right? To calculate this one, you'll be writing a function. So, that function may be a recursive function or it may not be a recursive function also. But the most easier one and the most appropriate thing will be to go for a recursive function, because multiplying the number with the next number, the result with the next number is it is a recursive process until unless you reach the value. That is, for example, I want to calculate 5 factorial, that is 5 into 4 into 3 into 2 into 1. Even like this also you can do 1 into 2 into 3 into 4 into 5. What I'm going to do is I'll start with 1, I'll multiply with I'll take a fact as temporary variable as 1 multiplied with 1, the result is fed into fact which is 1, and it is the result is multiplied with 2, and the result is stored in fact which is 2. Then this 2 is multiplied with the 3, and the result is stored over here which is 6, right? So this is a recursive process, my dear, right? So repeatedly you're doing the same. You're using the temporary result for the calculation purpose, which is nothing but recursion, right? You'll be able to understand this concept and you'll be able to apply it. So under Bloom's taxonomy, we have placed it under apply category. You'll be able to apply it. Just like in factorial, you have applied the concept of recursion. And if you go a step deep into this concept, you will be able to even understand whether to use a direct recursion or indirect recursion, right? I hope you know what direct recursion and indirect recursion is. If you do not, please do follow my channel and look at the video recursion algorithms where we have explained this concept briefly with examples. Okay, let's go to the third outcome, that is to represent standard abstract data types by means of appropriate data structures. Right? You must be able to understand, you will be able to understand the basic structures, right? The basic structures of data structure. For example, how a stack looks like, how a queue looks like. For example, I can say a stack will be linear in nature, whereas from one end either you can push the data or you can pop the data, and uh, it will be tracked by the by the counter, or you can whatever by the variable top, right? So top will always be pointing to the most recently inserted element into the stack, right? So this is the abstract. Then how we are going to define it, right? So looking at the concept of, as I said, we are going to learn data structures with the help of Python. As Python is an object-oriented programming language, take the help of the same, right? So take the help of we will take the help of classes, and we'll declare the abstract. We'll decide the abstract data type of any stack. Similarly, queues. If you look at queues will have two ends, right? So a front end and a rear end. In the front end, you are going to delete the data, and in the rear end, you are going to insert the data, right? An abstraction of the same will be declared using Python, and you will be able to understand, right? How to give how to declare them, how to use them, you will be able to understand. Okay, the next one, CO4. The outcome is a select appropriate sorting technique for a given problem. Very good point, you'll be able to understand. Then, what do you mean by this one, ma'am? Right? Let me explain you. You will be learning many sorting techniques. Say, for example, bubble sort, insertion sort, selection sort, quick sort. I'm taking a few in a random way. Okay, quick sort. Fifth one is merge sort. Sixth one is a heap sort. Okay, six I have taken. So as the course outcome tells you, you will be able to decide which sorting technique is appropriate here, right? So whenever you have a tiny list of elements to sort, use bubble sort, right? And its complexity will be less. Its complexity is order of n, right? So it will be like that unless your list is small, and is very easy because you will be comparing two consecutive elements and you will be sorting. It's a simple technique, but only the condition is if you have handful of elements. Insertion and selection are two similar ones. Okay, so their best cases will be when the list is already sorted and it is given to you, and their worst case will be when the order is in reverse. Say you are supposed to sort the data in ascending order and you have the data in descending order, right? So in that cases, insertion and selection will show you their worst phase, right? So even the list is a bit higher, they are fine. But when the size of the list raises, these two will take huge amount of time. So better go for divide and conquer techniques, which are quick and much. These two work for huge set of elements, as they divide the things into halves. With every iteration, they are going to divide the list into two halves and they are going to sort. Then coming to a betting between these two, quick and merge, the main point is quick sort. With every iteration, the pivot element, the element which you are choosing to be a pivot element, either the element which is placed in its least index, or at the highest index, or at the middle index, whatever. Okay, so that element will be placed in its appropriate position if the list is sorted, right? So with every iteration, you are going to place the pivot element in its right place, thereby dividing the list into two halves, left of pivot and right of pivot, right? So say, for example, there are a list of elements 1, 2, 3, 4, 5, 6, and you have chosen the first element to be the pivot element. After the first iteration, now the pivot element is placed in its right place. Now the left list and the right list, recursively use the same process. So quicksort will help you to divide the list into two halves with every iteration, right? So quicksort is going to show its best face only when the pivot value which you use divides the list into two equal halves. Did you understand? So pivot element, if it whatever the pivot element you are going to choose, if its right position is in the middle of the list, then quicksort's best case is going to occur, right? Or else, let us consider a scenario: the pivot element you have chosen is the second element, right? Appropriate place. Then right side, the left side list is one element, all the remaining elements are on its right side. Even this is the worst case scenario, right? So that is a point. This is how quicksort works, right? Coming to merge sort, even though its time complexity is very less, its space is very high. Why? Because if there are n elements in your list, it needs a temporary space of n elements to sort. Space complexity is very, very high in case of merge sort. If the size of the list increases, even the size of the temporary list also increases. We never know whether the system will be able to allocate such an amount of memory just for temporary purpose or not, right? So that is a drawback of merge. So all the 1 to 5 sorting techniques will be using linear data structures to start. Coming to the last one, sixth one is going to use a non-linear data structure, which is a heap. It can be a maximum heap or a minimum heap to sort the data. If you use max heap, you will get ascending, min heap, you will get descending, right? So this is a glance at all the sorting techniques we have. Now, by the end of this course, you will be able to judge which sorting technique you can use for the given list of elements to give you the best result. With every sorting technique, you will be given a brief knowledge on what on where it can be implemented, what is its time complexity, space complexity, is it in place, and is it a stable one or not, right? All these properties of all the sorting techniques you'll be learning. So once your objectives are met, now you are at a stage, the outcome will be you'll be able to decide which sorting technique is the best suitable for a given list of elements with the basic amenities you have in your hands, right? So that is the CO4. Coming to the next one, CO5. Let me explain you that with a small example. So CO5 tells us about searching techniques. There are two searching techniques, my dear. One is linear search and the other is binary search, which you are going to learn. Linear search is a simple searching technique where the key value which you want to search, you will be keep on searching from comparing with the first element till the last element, and you are going to judge whether you have reached that element or not. Keep on doing that. Binary search, here you are going, again it depends upon divide and conquer. Okay, so divide and conquer binary searches, it is going to divide the list into two halves, and with every iteration you are going to drop either the left sublist or the right sublist to search a key until unless you reach the key. But the prerequisite with binary search is it must be sorted in nature, right? That is a prerequisite for binary search. So once you learn the in and out of linear search and binary search, you will be able to understand their working, right? And the cases or the problems where you can appropriately use them. Let me give you a small example of the same. Say you have a linear search algorithm working on a fast computer A, and binary search is working on a slow computer B. Okay, and we know that the complexity, time complexity of linear search is order of n, whereas binary search is order of log n. Right? Log n is much more lesser. But when binary search works on a slower computer, it takes 1,000 units of time, whereas with the same list, even though the linear search complexity is high, as it is working on a fast computer, it will take zero point 0.2 units of time to execute, which says that system A, that is indirectly linear search, is going to give you 5,000 times faster. It all, the complexity always depends upon what kind of input you give to that, right? So let me take a graph on the same. That is the number of input elements you are going to give as input, that is input size. How your linear search and how your binary search are going to work. Say if 10 elements are given, within a second this is going to give the answer, and binary search may take uh, a much more amount, say 1 hour, for example, say 1 hour. If it is 100, it will take approximately 1 hour, and this will take approximately 5 hours. If it is 10 per 6, it will take approximately 5 hours. This will take approximately 5.5 hours. If it is 10 per 9, this will take 6 years. This will take 8 years roughly. 8 hours. So have a look. As the size of the input raises, linear search, even though it is working on a fast computer, its execution time is very high, whereas binary search execution time is very, very, very less. Right? So that you will be able to understand. You will be able to judge. So if the list of the size is less, linear size is best. If the size is high, binary search is best. Whatever the speed of the computer may be. But because I don't think we'll be ever using 10 power 6 to 10 power 9 size of elements, right? In real time scenario, we rarely use such huge values, right? So speaking on a ground level, learning about the complexities, that is the time and space complexities of all these algorithms, which we have covered in the first point itself. As I said, the first outcome is the backbone for all the remaining ones. Whatever the technique you are using, whatever data structures you are using, their working will depend upon time and space complexity. That is the backbone of your data structures, guys. You must be very, very strong in that. Okay. And the next one is you will be able to, the next, that is CO5, you will be able to understand the standards as you have first from the point number 2. Okay, outcome 2, 3, 4, 5. They were telling about understand, right? So CO3 tells you to abstract data types, right, of all the data structures, searching and sorting techniques. Once you understand all the three, apply them, right? You will be able to apply them, right? Good. Let's go for the next outcome. Then design and implement linked lists using for stacks, queues in Python. Okay, you are going to apply them. You already know you have understood the concepts of stacks and queues, right? In CO3 itself, you have understood the concepts. Now, implement them using linked list. Why linked list? Here comes the a small intro between arrays versus linked list, LL, right? So arrays and linked list both are linear data structures, no doubt in that. Every element is related to only one another element, even that is fine. The difference between these two is in arrays the data is stored in contiguous memory locations, whereas in linked list the data is scattered all over the memory. Each data element will hold the data as well as the address of the next node also, right? So Wherever there is scarcity of memory, or if the data set is huge in nature, to implement stacks and queues, it's better to go for linked list rather than arrays. Arrays, the constraint is you need to have consecutive memory locations for that, right? Which might not be possible in all the cases. So using linked list, understanding the concepts of linked list, you'll be able to apply stacks and queues using linked list in Python. Okay, so let's go for next outcome, which is 8. So explain the use of basic data structures, arrays, stacks, and linked queues in design problems. So we were discussing about the abstracts, right? With CO8, understand. You understand the concept with CO3, you understand the concepts of stacks and queues, and you have implemented them using arrays and linked list till CO7. Very good. Now, designing them. For example, say the example of a stack. As a stack, the basic application of stack will be expression evaluation, right? So have to do that. So for this one, the first step will be converting the given infix to postfix and then evaluate that postfix, right? In these two steps, we'll be using stacks. Then is it not problem solving, right? And one more applications of uh, uh, shortest path. Shortest path, you will be using graphs. Shortest path from source to destination, right? So I have to get that. Using graphs, you are going to do that. So the first example which I have taken using stacks, and second one using graphs, they're real-time problems, my dear. You have to design a solution for that. You know how to you know the concepts of data structures or the basic data structures. You know how to implement them, design them, the basic operations, right? That is insertion, deletion, updation, and all, you know, right? Now use them for real-time scenarios, right? That it will be covered in your outcome 8. You will be able to do that. That means whatever the operation your arithmetic logic unit does for expression evaluation, you will be doing it with the help of Python programming, right? Right. Next one. So extend their knowledge of data structures to more sophisticated data structures, right? So as I said, the non-linear data structure is a tree. So the basic tree will not be helpful in many cases. So we learn what a binary tree. Even the binary tree, putting a constraint on a tree saying that at max you can have, or every node can have only only two children. That is a constraint on binary tree. Well and good. Even that is not going to help us in few cases. So we go for BSTs, binary search trees. Binary search tree is a binary tree, but it puts again a constraint on them saying that, okay, the left children will have a value less than or equal to the parent, whereas the right children will have a value greater than the parent, right? That is one of the constraints. And if you go in deep, so if the list is ascending or descending, the BST which you are going to construct will be left skewed or right skewed, right? It will be drastically increasing its height in one direction, whereas the other side it will be none. To overcome that, we introduce AVL trees. Balance factor. So imposing balance factor concept on BSTs, AVL trees have come into the picture. What is the balance factor? The difference between the height of left and right subtree will be either -1, 0 or 1. That is AVL tree, right? So using rotations, either single rotation or double rotation, we are going to rotate and we are going to convert any imbalanced node to a balanced one. That is AVL tree. Even AVL trees suffer with time complexity. Why? Because if AVL trees are used only for searching operation, then it is well and good. But if you are using it, you are using AVL trees for an application where there are more number of insertions and deletions, then that becomes a tedious task once again. Why? Because always with every insertion you have to check the balance factor of all the nodes in your tree, starting from the root till the leaf node, right? You have to check all the balance factors. If there is an imbalance, rotate it, which takes major amount of time. That is a drawback. And one more drawback is whether you talk about tree, binary tree, binary search tree, or AVL tree, at every level, each node holds only one data value. Why is that constant? Is there any rule that every node must hold only one data? That will be enhanced in your B trees, which is a part and parcel of multi-way trees. Multi-way trees tells you that and multi-way tree of say order, a multi-way tree of order n tells that it can have n children and n minus 1 key values. That is, every node will have n minus 1 key values, right? So all these they so in when coming to learning the basic concepts, trees are only the basic concepts. All the remaining are the extended ones, and you will be able to learn all these extended ones. As I said, each and every, so with a drawback of version X, you are going to go for version Y, and all these versions you are going to apply, my dears. All these versions you are going to apply, okay, using Python. That is the outcome. Next outcome for your data structures is implementation. Design and implement. Design all these things and implement. So for example, let me take a random example of BST. The infix traversal of this one for binary search tree gives you data in ascending order. This is one of the applications. To get the data in ascending order, get the infix traversal of BST. That you are going to do using Python. That is, you are going to apply Python for real-time scenario. That is to get a sorted list, right? So these are few outcomes and few more to come. And these are the last three outcomes. So next is compare, that is course outcome number 11. Compare and contrast the benefits of dynamic and static data structures, implementations, and choose appropriate. So you'll be first you will be able to understand what static data structure is and what a dynamic data structure is, and how to choose an appropriate one in real-time scenarios while solving the problems. You'll be able to understand it. Then comes your outcome 12. Here you will be able to analyze the things. How efficient an algorithm is. How efficient and or data structure will be. Apply proper data structures for solving computing problems with respect to performance. You'll be able to analyze it. As I said, once you cover all the 11 outcomes, once the 11 outcomes are in your grip, it will be piece of cake for you to achieve the outcome number 12, right? That is to analyze the things, analyze the thing and take a proper decision, right? Next, the last but not the least one is effectively choose the concepts of hashing. Collision, that is for communication. Hashing is a concept which you are going to learn at the end. That is storing the data, that is huge data, with a piece of key as its unique representation, right? That is hashing. So hashing suffers with collisions. So how to resolve it? Either open chaining or separate addressing. Many techniques are there. Quadratic probing, linear probing, many techniques are there. You will be able to understand those concepts and you will be able to analyze them. So for a given problem, which is the best suited hashing technique, and if collision raises, how to resolve it, that you will be understanding. So overall, these are the 13 outcomes of your course, that is data structures, which will lay a path for your success, as data structure is core subject of your discipline. Coming to the outcomes, what are the program outcomes? First is engineering knowledge, then problem analysis, design and development of solution, and few more are there. I'll show you. So coming to the engineering knowledge, then how to apply whatever you have learned, how to apply. So you are going to apply them all. So the strength of this outcome is 3, and it will be evaluated by using your mid exams, quiz, and AATs, right? So it is having the maximum strength. Then problem analysis. So to identify, formulate, and review research literatures and analyzing the things for real-time applications. So its strength is 2, and even this will be evaluated using your mids, your quiz exams, and AATs. Next, and the third one is to design development of solutions. So guys, we'll be solving real-time problems which are there in data structures, like evaluations, where how a compiler works, right? For parenthesis balancing, have to have, or you can say have to implement trees, right? All we are going to learn, but not at industry. Will be going in industry point of view, but will not be able to reach the real time actual problems that an industry person faces. So I have given the strength test 2, and I'll going to evaluate it using seminars, conferences, and workshops. I do prefer people going for workshops and conferences to extend their knowledge. Being an academician, I can say that whenever we teach things, will be our point of view will be confined to the 50 minutes of the lecture per day and to the academic curriculum which is designed for us. If time permits, if the class permits, we are going to extend it, but it's an optional choice. So academic point of view, your knowledge will be confined, but if you want to expand your wings, do attend seminars or conferences and workshops to enhance using your participation in either seminar, conference, or workshops. We are going to assess your strengths in PO3 by attaining PO3. Coming to PO5, that is modern tool usage. Modern usage is the techniques, the basic techniques and the IT tools which we are going to use. Basically, the programming language which I am going to use is Python. The strength is 2, and using assignments and discussions, we are going to achieve the proficiency. Next, PO9, that is individual and teamwork, and that we can do in the class group or multidisciplinary group, dividing them into groups, giving a task to them, evaluating their performance and all. Okay. Next is communication. That is communicate effectively on complex engineering problems through discussions on innovations and presentations. We are going to evaluate it, right? These are the assessments, guys. Assessment of your proficiency in this course data structure, right? And the last but not the least one is your lifelong learning. Data structures is a concept of lifelong learning, but in the academic point of view, we are going to learn the basics, only the basics. So I have given a strength of 1, and which I'm going to evaluate using seminars, workshops, and short-term courses. Okay, so these are the program outcomes. Let's look at a mapping of the same. How your course outcomes are mapped to program outcomes. So this is the chart which gives you a demonstration on the same, right? So let me show you the course knowledge competency level, right? So when you learn data structures, the prerequisite for it is you must be having a basic knowledge on Python. That is what a list is, what a dictionary is, coming to object oriented complex concepts like what is a class, what is an instance of a class, what is a constructor, what are the things that you are going to define in a constructor and all, right? So keeping that in mind, I don't think you need to remember anything. All those are prerequisites. With the prerequisite knowledge in your hands, you are going to step in to learn data structures, right? So here the major point is to understand. See, 6 points go for understanding only, because data structure is a new concept for you which you are going to implement with your prerequisite, that is Python. It's altogether different story, but all the concepts which you are going to learn within here are new to you. You will be novice when you enter into data structures. That is, you might have not heard about what a stack is, what a double-ended queue, what is a circular linked list, what is AVL tree, binary search tree. All these terms will be every day with a new session. You will be hearing new terms which you need to understand. So understand is the key criteria over here. In Blue, when we go on par with Bloom's taxonomy, understand is the utmost criteria, basic criteria which I'm going to achieve when you learn data structures. And the next one is apply. So whatever you are going to understand, that you are going to apply, right? Stacks, apply them for evaluation. Queues, apply them for one or the other purpose. Trees, apply them for sort the data, right? That is heap sort is based upon trees. Graphs, get the minimum path. Use Prim's algorithm, Kruskal's algorithm, any algorithm, whatever the algorithm you are going to use. Get the shortest path from source to destination. That you are going to apply using Python. So whatever you understand, apply it. So even apply gets the crown of being the second winner. That is 4 points. Okay. Last one is to analyze. Analyzing the things. So analyzing the concept of hashing, right? Hashing is a technique, as I said, to resolve the it is a concept of storing a key value for a given huge value, and it should be unique in nature. And get if you properly implement hashing, its insertion, deletion, and searching operations must have a complexity of order of 1, which is next to impossible in real time scenarios. So let's try to achieve it by going for resolving the collisions which occur in hashing, that we are going to analyze. The hashing is not the only point. In all the phases from starting to the ending, we are going analysis will be a bit, that is the last token that you are going to turn. Once you understand the concept of stack, implement the basic operations using arrays and linked list, then go for the applications and apply them, then analyze what you have learned throughout the stacks. This cycle will keep on going for all the concepts in data structures. Understand the concept, apply the operations, understand its applications, implement it one of the real-time applications, and analyze what you have learned so far, right? So analyze is the third one, right? So these are the three Bloom's taxonomy levels which I am going to achieve when I learn data structures, right? So with this, I would like to conclude that we have seen the course objectives, outcomes of data structures in outcome based education, right? I hope you understood. And this is the basic video for your data structures. Once you understand it, it gives you an overview of what are all the things that you are going to learn in data structures. So do follow the channels and my videos so that you'll understand each and every concept of which you have heard over here in a detailed manner. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.